Hello, this video is created by Team 6 of CS6310 Fall 2018. My name is Neil and I will kickstart the presentation. Our presentation, we will be covering the introduction of our team, the deliverables, our design, the live demo of our code and the code walkthrough, and then how we tested the application.
My name is Bill. I worked on the use case diagram and also the unit testing.
I'm Mani Chaudhary, and I worked on the backend services and part of the deployment diagram.
I'm Komal Desai. I worked on backend and design documents mainly.
Hi, this is Jitendra from South Korea. I worked and designed UI and implemented UI and fixed bugs. As part of deliverables, like we have .ova, source code.zip, design.doc, all these three are on the GATech box folder, and then we have a YouTube video link for the video recording. Next, please.
For our design document, we have prepared 4 UML diagrams, 2 structural diagrams, which depict the structure of the system, class diagram and deployment diagram, and 2 behavioral diagrams, which depict the system's behavior to external actors. We have sequence diagram and use case diagram. First, let me start with the class diagram. Class diagram has clearly 2 major categories of classes. One is data classes, such as bus, stops, routes, etc., and service classes, such as Marta system helper. We have used singleton pattern design interfaces for reusability of the system. Next is the sequence diagram. In this diagram, we have covered all the user-initiated workflow. For example, how we initialize the system, followed by the move bus workflow, followed by the system coefficiency, change bus routes, etc. Please note, passenger management is done implicitly whenever move bus is executed. That's why passenger management related sequence will be part of move bus diagram.
So we talk about the deployment diagram where our implementation uses a standalone Java application which requires GRE 1.8 and it is running on Oracle VirtualBox. There are 5 components primarily: data, UI, services, exception handler, and test component.
And talking about the use case diagram, we looked at the various use cases of the application, like the initialize bus, create bus route, and update bus route. Also, we talked about the calculate system efficiency, and also we looked at how these use cases relate to each other, like how the create and update bus relates to the route changes. These are all shown in our use case diagram.
Yeah, now we will cover the demo of our system. So we have a working jar file, and then I start the jar file. So when we start the application, at the top we see that there is a panel which displays the system coefficients, and on the right side we have the system status, which is shown, which shows the positive as well as the negative messages that system encounters. We'll initialize this application. We'll provide a bad file name which does not exist, and see that the application does exception handling and shows the message that this file does not exist. Now we will load a file which is complex data file. So I select one of the complicated data files and the passenger distribution file and click confirm. So the application loads the data and displays the information on the middle panel. The bottom panel has the move next bus command, which when we click displays that the bus has been executed, the move bus has been executed, and I click multiple times and see that the number is changing of the bus number at the top. We have the rewind and replay bus functionality, which goes steps back and rewinds the bus for up to 3 consecutive times. Jitendra, now you want to.
Thanks, Neil. So we already saw initialization, move bus, and rewind. So a few other things that we have provided control to user and that we need, like we have set system coefficients and then bus parameters change. So set system coefficients, like we have K, speed, capacity, weighting, combined, and bus cost. So this input box, user can input either one or the all values, and he can confirm. So that will be taken and stored in the system, and then will update it on the status panel on the top. And then like bus, we can choose like when we click on the bus change parameter like speed, capacity, then input box will open, and there user can input the bus ID and then the corresponding the new value that he wants, either speed or capacity or the route and the stop. So that when he confirms, that will be stored in the system and it will be executed when that particular bus is moved next, and then that will be updated on the status panel, and then the status string will display that value, and then system coefficient will be calculated and then updated. There is a system coefficient refresh button as well that user can click to update it. Next, please.
Yeah. So now we will talk about the code, the way we have implemented. So on Eclipse, we see that we have 5 packages: the DTO package, the exception package, services layer, the test packages, the classes, and the UI classes. So within the services classes, we have an interface which talks about the methods, the initialize system, update passenger setup, move next bus, rewind bus, and so on. And similarly for those, the implementations are all stored in the system IMPL class, which is supported by the helper class at the back. Now on the UI, Jitendra, you want to speak about UI?
Yeah, thanks, Neil. So UI has a main, and from main actually when we start, then it actually opens a UI that basically a JFrame, and that JFrame has like 3 different panels. That is a J panel. So the top one is like for the bus status display. The second one is a bus and stops graphical, and there is status. And the bottom one is for the user to have the different control. So there are all those J buttons that we have in the bottom control panel. So when that button user clicks, so that the button handler will be called, and that actually will call the service layer, and then that functionality will be executed.
Let's talk about the DTO class package. In the DTO, we have data objects: bus, bus stop, bus route. These are simple data classes. Bus class keeps the current value as well as the new values which the user may have set. Those become effective only after the move bus action has been completed. Record bus event is used to record the state of the bus and the stop object. This is the class which we use during the rewind and restore the objects from the event. We maintain only the 3 record bus event in our map. Bill?
And when we're talking about the unit testing, we looked at the various service classes and also the utility class. We tested the initialize system and also the move next bus and rewind and update system. And also we tested every method within the utility class. Everything is combined together into the test suite.
Thank you very much, Bill. So that ends our presentation. Thank you.
Thank you very much.
Thank you.